Okay, so just to recap from yesterday, the steps that we're going to follow, there's 5 steps. Step number 1 is to check to see if there's a number in front of x squared. There is not, it's a 1. So now my second step is to move the constant. So I'm going to subtract 12 from both sides of my equation, and I get x squared plus 7x equals negative 12. My next step is to take the b term. So again, remember it's ax squared plus bx plus c. The b term is the number in front of x. So I'm going to take this 7, I'm going to divide it by 2, and then I'm going to square it. This is what I'm adding to both sides of my equation. Now, if it's easier for you, instead of showing that, I'm going to be filling in here. Let me see. What I'm filling in on both sides is 49 over 4. Now, it might be easier when you put it into the left side if you leave it like this. Because then when you go to factor the trinomial here, it's just whatever this number is without the square. You would put the square outside here. So as long as you remember what you got when you divided by 2, that's what that binomial or that trinomial factors into. So the hard part is over here where I have to add these, but really it's not that bad. I'm going to turn negative 12 into a fraction. I need to find a common denominator, so I can multiply top and the bottom by 4, and this becomes negative 48 over 4. And then I add them, and I get 1/4. Now I need to apply the square root method. So I would square root both sides, and I get x plus 7/2 is equal to plus or minus the square root of 1/4. Remember, we can apply the quotient property here, and what we could do is square root each one individually. Square root of 1 is 1, square root of 4 is 2. So now this becomes x plus 7 over 2 is equal to plus or minus 1/2. Now, when it turns out that this is a perfect square on that right side, we need to simplify and get the actual 2 solutions. So normally what we would be doing is moving over the number that's with that x, isolate x, and normally we would be leaving our answers like this. But when this right here is not under a radical, we've got to do the problem. So we're actually going to do x is equal to negative 7. And if you wanted to write this all together, negative 7 plus or minus 1 over 2, you could do it that way. So this now becomes negative 7 plus 1 over 2 and negative 7 minus 1 over 2. I'm going to simplify each one, and I get x equals negative 3 and x equals negative 2. Or, nope, sorry, negative 4. I'm dividing by 2. So x equals negative 3, x equals negative 4. So when you have these odd b terms, do not make it a decimal. Leave it a fraction. Otherwise, it's going to be impossible to factor. All right, let's try the next odd example. Again, I still have only a 1 in front of my x squared. So that was my step 1, was to check. It's only a 1. I don't need to divide anything. Step 2 is to move the constant. So x squared minus 3x equals 6. Step number 2, take the b term, divide it by 2, and square it. So x squared minus 3x, and then I could show it's going to be plus negative 3/2 squared. Over here, I'm actually going to do it and get 9/4. Now, if that confuses you by putting it in here like this, You can also show that this is really 9/4. Either way. So now I need to factor the trinomial. It becomes x minus 3/2 squared equals, I'm going to change the 6 over 1 plus 9/4. I'm going to change it into 24/4. Add them, and I get 33/4. I'm now going to apply the square root method. I get x minus 3/2 is equal to plus and minus the square root of 33/4. Again, remember, I can apply the quotient property, break it apart, give it its own little radical, and then the square root of 4 is 2. So now I have x minus 3/2 is equal to plus or minus the square root of 33/2. I now need to move the 3/2 over, and I get x is equal to 3/2 plus or minus square root 33/2. Notice they have the same denominator, so I can also write it like this with just 1, 2 in the bottom. Again, remember on the SAT or PSAT, they might even pull it apart. This is 2 answers. So this is why yesterday on the quiz, if you forgot the plus minus, you left behind one of the answers. So that's why you lost half credit. So the plus minus is big. All right, so that was that answer. Now we're going to do the part where there is a number in front of the x squared. So step number 1 is to check to see if this number is a 1. If it's not, then I need to divide everything by that number that's in front of the x squared. So I'm dividing everything by 9. So then I'm now left with x squared. I'm going to reduce 12/9 and make it 4/3 x, and then minus 1/9, and then 0 divided by 9 is just 0. Now I have it set up like a problem that I had yesterday. I need to move the constant, that's step 2. So I'm moving the 1/9. X squared minus 4/3 x equals 1/9. I now take the b term, divide it by 2. When it's a fraction, dividing by 2 is the same thing as multiplying by 1/2. So I'm going to simplify this, and I get negative 2/3. I now take the negative 2/3 and I square it, and I get 4/9. This is what I'm adding to both sides. So you can either put in here that you're going to be adding negative 2/3 squared, or you could write it as x squared minus 4/3 x. Show that you're putting in plus 4/9. Over here, this becomes 5/9. Now I need to factor the trinomial. So again, it's sort of beneficial to do it like this, because this is what your binomial squared becomes. And then equals 5/9. I now apply the square root method. X minus 2/3 is equal to plus or minus the square root of 5/9. Again, I can give each one its own radical. This would simplify into square root of 5/3. And now I need to move the 2/3. So I would add 2/3. So x is equal to 2/3 plus or minus square root 5/3. Again, if you want to show this with just 1/3 in the denominator, you can do that also. Yes?
So when we're doing the odd ones, most of the time, those are going to have
Yeah, sometimes they don't, and then you could just leave them as two separate fractions. But if they do, you could combine it into one. All right, again, I've got a number in front of x squared, so I need to divide everything by 3. So I get x squared plus 2/3 x minus 5/3 equals 0. Step 2, move the constant. So I'm going to add 5/3 to both sides. Next step, take the b term, divide it by 2. So 2/3 times 1/2, dividing by 2 is like multiplying by a half. So then here, I just get 1/3. And again, I square the 1/3. So what I'm adding to both sides is 1/9. So in here, you could put 1/9 squared. Over here, 1/3 squared. Over here, I would show it as 1/9. All right, so now factor it. It becomes x plus 1/3 squared. I need to find a common denominator between 3 and 9. So 5/3 plus 1/9. My common denominator is going to be 9, so I'm going to times the top and the bottom by 3. This becomes 15/9 plus 1/9. So this side becomes 16/9. I now apply the square root method. X plus 1/3 is equal to, these are both perfect squares, so this would become 4/3 plus or minus. And now I would just move the 1/3 over. So minus 1/3, x equals negative 1/3 plus or minus 4/3. Again, my radical disappeared. I need to figure out what these two solutions are. So x is equal to negative 1 plus 4/3, and x is equal to negative 1 minus 4/3. This becomes 3/3. So my x equals 1, and over here, x equals negative 5/3. So my two solutions are 1 and negative 5/3. Yes?
If you're dividing it by 2 and then squaring it, then shouldn't it be, at the top, shouldn't you be multiplying the whole thing by 2 because I keep saying flip?
So, but it depends on what the number is. Like multiplying by 2 and squaring are two different things. Because like if I do 4 squared, it's 16. If I do 4 times 2, it's 8. Does that make sense?
I don't mean that. I mean like if
Oh.
you're...
This one, radical disappears. You can figure this fraction out. You can do 1 minus 4 and 1, or negative 1 plus 4 and negative 1 minus 4. Does that make sense? And we can actually get a number for it. Still, same thing. We need to make sure that the number in front of x squared is a 1. And to make it a 1, we divide by itself. So divide everything by 3. So then this becomes x squared minus 4/3 x minus 1/3 equals 0. Step 2, move the constant. X squared minus 4/3 x equals 1/3. Take the b term, which is here, negative 4/3, divided by 2, which is multiplied by 1/2. Simplify, and I get negative 2/3. I square it, and I get 4/9. This is what I'm adding to both sides. Again, if you want to put it in here as just what you got when you divided the b term, just so when you go to factor this thing, you don't have to think about it. And now I need to find a common denominator between 1/3 and 4/9. Again, it's going to be a 9. So multiply top and the bottom for the first fraction by 3. This becomes 3/9 plus 4/9, and I get 7/9. Apply the square root method. X minus 2/3 is equal to plus or minus the square root of 7/9. Again, remember you can root them separately. So the square root of 7/3, so plus minus square root 7/3. Move the 2/3 by adding it to both sides. So x is equal to 2/3 plus or minus root 7/3. Again, if you wanna, because it's already got the same denominator, you can put it together with just 1/3. Either way, I'm okay though with you leaving it apart if you wish. Yes?
For the other one, why did we have to find two different solutions for plus or minus, but for this one we just left it?
So whenever you do the square root method, if a radical is left here, we don't know what, we're not using a calculator, so I don't know what the value of square root of 7 is. I could give you two solutions. What you could do here is do 2 plus square root 7/3 and 2 minus square root 7/3. If I'm not using a calculator, I can't, I could approximate this, but again, I'm not going to make you do that. When it's a radical, you can leave it like that with the plus minus. All right, next one. Again, step 1, make sure that x squared term has a 1 in front. So to make it become a 1, divide everything by 5. X squared minus 7/5 x minus 1/5 equals 0. Step 2, move the constant. X squared minus 7/5x equals 1/5. Step 3, take the b term, divide it by 2. So again, it's a fraction, so I'm just going to multiply it by 1/2. This gives me negative 7/10. I square that, and I get 49/100. So again, you can show in here that it's really negative 7/10 squared. Over here, I would show what we're actually adding. So now factor it. So it becomes x minus 7/10 squared. I need to find a common denominator between 5 and 100. And that's going to be 100. So my new fraction here is going to be 20/100. So now this becomes 69/100. Apply the square root method. X minus 7/10 equals plus or minus 69/100. Again, you can square root them separately. So x minus 7/10 is equal to plus or minus square root of 69/10. 69 can't be broken down, so I'm going to leave it alone. Just move the 7/10 over. So x is equal to 7/10 plus or minus square root of 69/10. And again, if you want to put it with just 1/10 in the bottom, you can do that. Okay, everybody ready? Need everybody to wake up. To wake you guys up, because I know some people are falling asleep here. Okay, here we go. So notice the instructions here. It says find all solutions, real and imaginary. Now, it may not specify to be a clue for you to find real and imaginary. You should consider this on every problem you do. When you get an I in your answer, that's your imaginary root. Now, common mistake here is people are going to just try to move the 8 over by subtracting it, and then they're going to cube root both sides. You will miss out on the imaginary. You will only get the real root. So the correct way to solve these cube problems is think SOAP. We need to factor the cube. Everybody remember the SOAP pattern. So remember we had cube root, so let's just go through this. So x, this is what we did at the beginning of the year. So we cube root this, we cube root this. The cube root of this one gives me my a. The cube root of this one gives me my b. And then I put it into the SOAP pattern. Remember, a plus b, and then a squared. In this case, it's a plus sign. So then I do a times b plus b squared. Same sign, opposite, always positive. If it were a subtraction sign, then the pattern is a minus b, same sign, and then a squared plus ab plus b squared. So you cube root the numbers, and now we put it into the pattern. Now, the first binomial I get from my a plus b here, that's my real solution. That trinomial, remember, can never be factored. That's where we're going to get our our imaginary, and we're either going to have to do completing the square or quadratic formula to get the imaginary root. So this cube is putting everything together. So let's go ahead and finish this now. So I'm going to use this pattern right here. Again, I'm thinking SOAP. So what I'm going to do here is x plus 2. Then I square the a, multiply the a and the b. It gets opposite sign. And then I square the b. I've just factored the x cubed plus 8. This is back in the review chapter where we factored the cubes. Now we're applying it to solving. Now, I need to set each one of my factors equal to 0 and solve. So I take the x plus 2, set it equal to 0. X squared minus 2x plus 4, set it equal to 0. Now, if you recall, when we did this on the review chapter test, that trinomial that we get can't be factored. I know a lot of people try to, but you can't. So the only way we can get what x equals for that trinomial is completing the square or quadratic formula. And I can show you both. For me, probably what I would do is if that b term is an even number, I would do completing the square. I think it's faster. But if it's an odd number, maybe do quadratic formula. It's not a set method. You can pick when you're factoring this cube or solving this cube. So my real solution comes from the binomial. So my first answer is x equals -2. If you would have just cube rooted the x and the 8, or when you moved it over it was a -8, that would have been the only answer you got. And more than likely, you're going to get the question wrong on the test. You now need to factor this thing. And again, we can't factor it, or we actually have to solve it. So I'm going to do first completing the square, and then I'm going to also show you it with quadratic formula. You can choose. You don't have to do both.
The quadratic formula won't be on the test, right?
It is.
Oh, it is on the test?
Yes. So the test is 1, 1, 1, 3, and 1, 4. Everything we've learned.
But I'm trying to say is that if you won't have the formula on the test, I have to
Oh,
do it by memory.
correct. Yes, we don't give you the quadratic formula. You need to memorize it because they don't give it to you on the SAT or the PSAT. You have to memorize it. So you have to memorize the quadratic formula and the steps for completing the square. All right, so let's go ahead and now work with this trinomial. I'm going to do it with completing the square first because that's what we've been practicing. So x squared minus 2x plus 4, move the constant, x squared minus 2x equals -4. Take the b term, divide it by 2, square it. So I get -1 squared. So what I'm adding here is -1 squared, and then it's just +1 on that right side. So now I factor the left, and I get x minus 1 squared, and then I get -3 over here. Apply the square root method. x minus 1 equals plus or minus negative square root of 3. Okay, remember this trinomial is giving me my imaginary solutions, so I'm getting an I out of this. So again, x minus 1 equals plus or minus I square root 3. Then we move the 1. So x is equal to 1 plus or minus I square root of 3. So I have 3 solutions here. I've got my real solution from up here, and I have my 2 imaginaries. So again, they might write it as x equals negative 2, x equals 1 plus I root 3, and x equals 1 minus I root 3. I'm okay with you leaving it like that. Yes?
If we do the quadratic formula, do we have to simplify? Because like I did it and I got 2 plus or minus 2i's square root 3 over 2.
You have to reduce it. Okay, so now I'm going to do what she just did. So I'm going to use quadratic formula. So again, here is my equation. My A is 1, my B is negative 2, and my C is 4. I'm going to plug it in. Opposite of B plus or minus B squared minus 4 times A times C, all divided by 2 times A. So I'm going to plug it in. So opposite of B would be positive 2, negative 2 squared minus 4 times 1 times 4, all divided by 2 times 1. 2 plus or minus 4 minus 16 over 2. I now get 2 plus or minus negative 12. I now need to simplify the negative 12. Again, common mistake students are going to make is they're going to think you can cancel these 2 out. You can't cancel out until you simplify the radical first. So I need to break down the negative 12. The negative 12 is going to turn into negative 12, and I can make it 4 times 3 times negative 1. This will give me 2i radical 3 over 2. Now I can reduce. This becomes a 1, a 1, a 1, leaving me with 1 plus or minus I square root 3, which is the same answer I got when I used completing the square. Yes?
I never look inside the radical.
Correct. The I comes out. You're square rooting the negative 1. Pretty good. So when you get to the factoring the trinomial part of the cube, you can choose completing the square or quadratic formula, whatever you're more comfortable with. Let's try another example. Again, common mistakes. People are going to think they can add the 27, cube root both sides, but that will only give you the real solution. You will lose out on the imaginaries. So again, think SOAP here. So again, I'm going to cube root the x cubed, cube root the 27, and I get x, and I get 3. So my pattern here is x minus 3, square the x, opposite sign, square the 3. I now set each of these equal to 0. So my real solution comes from the x minus 3. So one of my answers is x equals 3. Don't forget to write that on the line. People get so hung up on factoring that trinomial or trying to solve it with the quadratic or the completing the square. This needs to be listed on the line as one of the solutions. People forget to put that there. All right, this one, it's an odd number in the middle, so I'm going to do quadratic formula. However, you can still do completing the square. We just did a bunch of examples. So if I do quadratic formula, my A is 1, my B is 3, my C is 9. So I'll plug it in. So opposite of B, plus or minus B squared minus 4 times A times c, all divided by 2 times a. So negative 3 plus or minus 9 minus 36 over 2. 9 minus 36 is negative 27. I need to break down the negative 27. I can break this into 9 times 3 times negative 1. I get 3i radical 3. Problem with quadratic formula is you're going to have to simplify the radicals. So if you're not good at that, that might be a bit of a challenge. So negative 3 plus or minus 3i radical 3 over 2. So my 3 solutions are the 2 imaginary that are listed right here, plus the 1 real solution that I got right there. So 3 solutions here. Now, you could have also solved this with completing the square. It's, again, whatever you're more comfortable with. Yes. Again, we need to soap this thing. So cube root it. Cube root of x is x cubed is x. Cube root of 64 is 4. Same sign. Square the x. Opposite sign. Square the 4. Set each of the factors equal to 0. So my first real solution is x equals negative 4. And now to get the imaginary, quadratic formula or completing the square. So again, if I go ahead and do completing the square, because I've been practicing this a lot, let's do another one. Again, move the constant. X squared minus 4x equals negative 16. Take the b term, divide it by 2, and square it. So negative 2 squared gives me 4. So I'm adding 4 to both sides. So this is really negative 2 squared or plus 4. So then x minus 2 squared equals negative 12. Square root both sides. X minus 12 equals plus or minus square root of negative 12. Break down the negative 12. This becomes 2i radical 3. Add the 2. X is equal to 2 plus or minus 2i square root 3. So my 3 solutions are x equals negative 4 and then the 2 imaginaries here. Again, if you need to see it pulled apart, it's 2 plus 2i radical 3 and 2 minus 2i radical 3. X equals, and then the negative 4.